Okay, so today some of the information will be redundant or has been explained previously, so that the thing that been covered during the previous class we will go faster, just the matter to ensure that you are able to read or recap regarding the important remarks. Okay. Okay. So today we will cover more into the solar geometry, solar relationship instrument, and also the solar pathfinder. Okay, so pathfinder. So I think this one has been covered previously, so I just skip this one. This one as well. Okay, so this is the solar class and season. Okay, and P refer to the North Pole. Okay. So before we go further, everybody can hear me clearly? Okay. Yes. Okay. Thank you. Thank you. Thank you. All right. All right. All right. So you are there. You are there. Okay. Okay. Basically, so how to start? Okay. Some of the country will experience the four-season country of four season, autumn, spring, okay, summer, and winter. Yeah. So some of the country will experience only one season or one or two season only, which is dry season and wet season, same as Malaysia. Not sure about the Yemen and Sudan. Is that they experience the four season? I would think so, but I think maybe Khalid or G can mention in the chatting box is that they are experiencing their country for Sudan and Yemen experience the four season country. Okay, so this is not North Pole and the South Pole, which is the top and bottom of the part. So in the middle of the session, in the middle of the Earth, so we mainly mention the equator, okay, equator or the degree for the latitude, longitude, latitude is 0 degree, and then increasing by the latitude for specific country. Okay, so this is the thing. So no, as you know, by default, our Earth is not that, I would say, it's quite tilting a bit, this 33 degree, okay, from the axis of this North Pole and the South Pole, okay, by having this kind of tilting, so we can have the season and etc. So knowing that the Earth will spinning the eastbound and spinning surround the sun, so it will give you the day and night time and also the season for respective month. Okay, so of course they have the certain months experience the winter, autumn, spring. Okay? So it depends on the location that we turn around by facing or opposite the sun ray or the sun, which is you can try to discover this one later. Okay, so this the, I would say, just basic annotation, which is northern is N, northern or north, nano is south, so north south east on your right hand side, west is your left hand side. Okay, so the tilt refer to the latitude. Okay, latitude. So for example, for um, Sudan, the latitude is 14 degree north. Okay, so the tilt should be 14 degree. And for the Yaman, also 14 degree north. So they sharing the same tilting angle for the solar module. Okay, latitude. So as I mentioned previously, the highest irradiance will attack to the panel with the perpendicular situation, which is, let's say, in Malaysia, we have almost, for example, we take 0 degree due to the um, latitude. So we should place our solar module horizontal with 0 degree to get the irradiance maximum 90 degree perpendicular. So by referring to this small house and this kind of the straight line, it shows that every single time and have their own dedicated sun path. For example, to make it very quick, let's say this one is root on one day, okay, second day, and third day, or this root for the January, this root for February, and this root for March. In other words, every single time or daily basis or monthly basis, they have their own dedicated route. There's not same route that I experienced for the sun ray. Okay. So meaning that, let's say this is the start of the maybe 1st January, then might be perhaps this is the 2nd January and until um, end of month. So as a person who enter this kind of session, we should know the behavior of the sun ray. It's like that. It different with the country as well. For example, let's say uh, Malaysia, this kind of route, but maybe Sudan, um, this kind of route, or maybe Yemen, this kind of route. But the big idea, every single location during at any time have their own dedicated sun pass. So that's why before we install the solar module or solar array, we need to assess the particular area to ensure that we gain as much as we can for the use of solar or sun ray. Okay, or else we might experience the low irradiance, which leads to the low output or low efficiency. Okay. So this the um, important notation that we use throughout the world regarding the signage or symbol that we use. It might be different in terms of the signage, but the term are almost the same throughout the world. So, for example, sun altitude or sun altitude. Okay, so this one is the sun altitude. Sun. It's not the moon. So it's sun. It's like a moon. Sun. So the angle from the horizontal is the sun altitude. Okay. So this blue one is the PV module. So the most important part, this one, this PV with the horizontal plane, which is the beta PV or the T angle, again, T of PV module, which is this one. Okay. So by referring to the source 0 degree, okay, So towards the sun azimuth, okay, sun azimuth, and towards to the PV angle is PV azimuth or azimuth of the PV, this one, okay, by referring to the source zero. And then what else? The angle, azimuth, sun altitude, sun azimuth. So that's the four term you need to remember or to understand to ensure that you not wrongly use the term accordingly. So it should be in your mind. The crucial part is the angle, okay, the angle which is PV with the horizontal, the degree of this one. I'll try to sketch this one. Okay, this one is the T angle. All right, so this one is T angle or beta PV. Is dependent. Okay, so this is the most common people use. What's the slanting? What is the angle? So basically, by technical, we mention it still angle of the PV model. Okay, so this is another term of the sun, which is the azimuth. Okay, azimuth. Sorry, zenith. Zenith is the angle from head, which I will stand to the sun ray. So this one. So that's the zenith. Another term of the solar uh, direction, which is you need to know as well. So sun azimuth, okay, so this is the same. So as I mentioned previously, the the maximum irradiance can usually obtained by surface of perpendicular. Okay. So let's say your PV module, you are putting this T angle. Okay, let's say this is the T angle, okay, and this is your PV. So your sun ray should be perpendicular, okay. Yeah, to get maximum irradiance. Okay. So always remember that because that is the one of the factor can produce the high output or better efficiency. So I will skip this one. Okay. So this is the thing that's mentioned just now related to the every single moment and latitude have their own path. Okay, so they try to examine this sun path, okay, by conducting some sort of um, study, and they found that every single time with the dedicated location have their own path. Okay, so you need to know it wisely to ensure that you can appreciate the information related to the sun part or sun chart. This can share you what is the sun chart look like afterward. Okay, okay, so this is the sun chart, the sample of the sun chart. Okay, sun chart, manual or computerized. Also, we will go for the manual version. Okay. Simulate the skyline of surrounding. Okay, simulate the skyline of the surrounding is more related to ensure which place have the shaded or the blockage by the surrounding. Okay, so this kind of approach able to examine the place that we want to install the solar module or array to get the available sun ray at that particular location to, to increase the efficiency, the output. The main period of partial shading. Okay, so this is the thing. Okay. So normally how this is how he's do like. Okay, so we'll mention for you afterward with the actual sun chart. Okay, with the actual sun chart. Okay. Before we go further, so this is the solar radiation. Normally, normal people will mention it the sun ray or sun or solar intensity or etc. But technically, we should mention it as the solar irradiance or irradiance. Okay. Irradiance means watt per meter square. Irradiation watt hour per meter square. So these two differently. Okay. Polarization. So this is the visible light, visible spectrum wavelength, 0.4 to 0.5 micro wavelength. Micrometer. Direct and diffuse. So sun ray for solar radiation, for solar irradiance. No, commonly we have two types, which is the direct and diffuse. And part of the light absorbed, scattered, first atmosphere, vapor, dust, and vapor. I think maybe you can show it over here. Okay. So for the direct, normally they claim from the Earth or from the sun. They say this is the sun. Direct means that it's direct to the Earth. Okay. For the diffuse, it is the remaining after it through the sky. Okay. So so this direct is direct from the sun to the Earth, and diffuse is remaining irradiance that penetrate obstacles such as the sky before it reach to the Earth. Okay, and sometimes they undergo the water vapor, dust, and ozone from the atmosphere or the surrounding before they reach the Earth. Okay, so that's the difference in the diffuse and direct. So normally, for the player related to the solar, they will go for the direct. Okay, means that there's no interference in terms of the sun ray itself. But in Malaysia, we have the cloudy and sky. I mean, it's a blockage for the for our country. So normally they will go for this kind of type of solar radiation to get the maximum irradiance. Okay, so this is the intensity and color content of irradiation is function of length and pass through the atmosphere, absorption and scattering. So Malaysia, where's Malaysia? Malaysia is over here. Okay, Malaysia is over there. It's slightly in the range of 3, 4, 5. For we say try to erase this one. Okay, in the range of maybe 3, 4, 3, 4. Okay. Okay, so for student, who is student? Student somewhere is student. Student is somewhere over here. Wait. Student at Yaman somewhere over here. Is that correct? No, sir. Oh no. Which part? This one. This way. This one. A, B. B, right? Okay. Sorry, Khalid. Uh, Overshoot. Overshoot. Okay. So it means like Yemen and Sudan are quite high in terms of the irradiance intensity, which is offer a better condition of solar installation because by geographically they already receive a very high uh, irradiance for that particular area compared to the Malaysia, it's lightly light yellow in color, 3 to 4, and perhaps for Yemen and Sudan, they go for maybe 4, 5, 6, something like that. Okay. So that's the case. Okay, so that's the case. So this one, Australia, right? So Australia also some of the location have a quite high number of irradiance intensity, and some of the area is very light intensity. Okay. So it depends. This where we need to check whether the particular location geographically is already blessed with the sun intensity before we undergo for the installation or propose the solar system for that particular location or area. Okay, so I will just go this one very okay. So IR, what is the IR? Infrared. UV is the ultraviolet. Also, this the visible light, which is this kind of range of spectrum or wavelength. Okay, so normally we typically we use the measurement of the AMS 1.5, okay, because one refer to the travel throughout the atmosphere, which is when it comes to the Earth. So AMS is 1.5, so we go for the 1.5 references instead of the one. So normally they install the PV on on the Earth, kan? Okay, so this is the another data related to the visible light, which is this the wavelength. Okay, so here, so the whichever color that we can see now is referred to this kind of wavelength. Okay, so those who are what cannot be seen is either ultraviolet or infrared, which is some of the wavelength might be harmful to us. So that's why some of the people uh, at the beach, they using the sunblock or etc. just to protect their skin and something. So yes, we need to go this one. Okay. Spectral irradiance. So it's quite high. So normally we go for this yellow one. This yellow. Okay. So which is in terms of the watt per meter square. In terms of the square, we are in the range of the 114 actually. 1,400 maximum. And then until we reach at the earth, so this is the range. So basically, do you have any idea what is the maximum irradiance that um, receive on Earth from the sun, from the outside the Earth, after it undergo all the journey and travel through the atmosphere and etc. until reach to the Earth? Any idea what is the irradiance? 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000, 1000, 3000. Any idea? What is the um, irradiance? I would say irradiance. Wearing, okay, 1000. Anyone? Anyone to try? Okay, 1000. Okay, anyone want to try? What is the irradiance that receive with the Earth? Okay, more or less the irradiance. I mean the maxima I would say to the Earth lah, to the Earth 1,400 wavelength. And normally in Malaysia we can reach I mean 1, 1, 2, 1, 3 or 1,200 or 300. And but in general maximum average 1,000. Okay, maximum. But for the condition of the typical or normal irradiance for Malaysia, I would say in the range of 6 to 700 watt per meter square. Okay, so at least you can, I would say, but it depends on time. Okay, of course, during the morning side, just the beginning, and also the afternoon side, and the sundown. So it's slightly lower compared to the midday. Okay, midday we claim the midday from 12 to 2 p.m. Okay, so try to capture as much as we can during that time, because afterward or before that, the sun is not that high irradiance or maybe not that high intensity, which is affect to our system. Okay. Maximum annual yield. Okay, so basically when we refer this kind of block, it refer to the 100 means that, let's say this the latitude for that particular location. So means that we need to perpendicular to this place or plane to get the 100% of irradiance. Okay, but let's say we wrongly put, let's say we should have the sun ray is like this, but we put it cross like the 70 this one, but we put the PV like this, so it might gain only 70% of the irradiance. Okay, so we need to be careful to place our PV module or array to ensure that we are placing PV according to the peak angle to get the maximum irradiance. Or else, there's nothing much, I would say, wrong, but it's just the matter of you are not getting the high irradiance, which refer to the maybe you need to spend more another PV module, which is costly to cope your power required, right? Let's say, for example, you can only manage to have only one PV by placing the correct peak angle, but with the wrongly placing your PV module or array, you need to spend maybe two or more PV module. It's just the method to capture the irradiance, which is not wisely spent in terms of the money and also for the space area. Okay, so let's say if you are facing this way, you might go for the only 75% of capturing your irradiance and etc. So this diagram just to show that how crucial to place your to install your PV or your array to ensure that you can get the maximum irradiance. Okay, automatic angle depends on the latitude and local vehicle data condition. Adjustable tilt. Okay, tilts refer to the tilt angle according to the year and season. Okay, so that's the southern orientation of the sun in the southern hemisphere. Okay. So far, any question, guys? Go to the chat. Any question? No problem. 1,000. Yes. Less 1,000 watt per meter square. Um, okay. So no question. We proceed the next slide. Okay, so optimal the angle of UV array. Okay, as I mentioned just now, direct sunlight, which is, let's say this is your PV. Okay, this one is your, let's say, okay, so this one is your PV module. So it should be perpendicular to the sun ray, right? So that is the trying to say. Let's say this kind of your installation, so the maximum is the perpendicular this way, the sunlight. Okay, so this kind of arrangement, you need to investigate what is the T angle. Okay, and of course you need to know is that T angle same with your latitude. Okay, to ensure you get the exactly the perpendicular T angle. For Yemen and Sudan, they are fortunate because they have the high intensity of the sun ray, as well as they have the 14 to 15 degree latitude. So in other words, to place your PV colored and jet, you should place somewhere this angle, which is 14 or 15 degree, okay, and facing south, okay, facing south, meaning that north, south, let's say not south, let's say this one is east, sorry, east, west, okay. So for the location, Sudan or Yemen, they are recommended to install 14 degree facing south, or to obtain the maximum or perpendicular of the sun ray throughout the year. Okay. Okay. Radiance, radiation, and illuminance. Okay. So these the three different terms that might be wrongly used by the, I would say by the public, or maybe those are not taking the RE renewable energy subject. Because these three terms give you a huge difference from each other. Various different terms are even used dealing with the solar application. However, terms are often incorrect. Okay, even some of the solar specialists. Sometimes it's not incorrect from the solar specialist, because sometimes they want to deliver or convey the message of the term to the person who are not familiar with the renewable energy or solar uh, environment. So they try to mention the things that maybe the the student or the participant able to imagine or able to translate or easy to understand. So that's why some of the uh, specialists mention a common or general term in the sake of to get the idea what is the thing that can be imagined by the participant. Yet actually mostly they are not about the irradiance, irradiation and illuminance. Okay, so this thing you need to say mention on remember. the specific radiant power or radiant flux per area is the irradiance. Okay, watt per meter square, the symbol is the E. Okay. Irradiance, watt per meter square. When it relates to the hour, it can become irradiation. Okay, irradiation, and the symbol is H. H. Okay. What about the illuminance? Yes. Oh, we got the question from our friend. So I would like to ask, the sun pass is different from time to time. Can we say that by using PV with solar pass tracking system, we can get the maximum efficiency? Okay. Is it worth to fit PV or PV with solar pass tracking? Okay. Um, how to? Yeah, I think Warren, I will try to complete this one first. Afterward, I will try to respond with your question. Is that okay, Warren? Okay, so thank you. Okay, okay. Okay, so for the illuminance, there's a two different thing with the sun ray. So normally for the illuminance, they will call this kind of lighting in terms of the light bulb or whichever light or lighting in the residential or in your domestic appliances. So they go for the daylighting purpose for the illuminance. So they go for the lux and or LX and lumen per square. So do not confuse the illuminance and also for the um, irradiance. Okay, so actually we can have this kind of software related to the illuminance. I think I try to share with you guys my meter. Okay, this one. Okay. Oh, sorry. No, you cannot see it. I will try to stop this one first. Stop sharing and try to show you the thing. Hold on, eh? Just a second. So this the Lux Meter. You can install it uh, via your phone to check your illuminance or lux in your house. And then just to okay. So right now, yes, um, 241 lux means that considerably sufficient lighting, okay, for the for today class. I will share you the things. Okay. So hold on, eh? I will see this. Okay. So this is the sample of the lux. Okay, I just give you via my um, our WhatsApp group of the lux, so that you can install by your own your lux to check your lux in your house or in your room. Okay, because some of the activity refer to the special lux. Special lux means that if you want to reading, uh, it recommended 300 lux. If you go for your toilet, it might be 100 or 200 lux, kind of. So that's the approach of the energy management actually. So do not put all the things open for the purpose of waste of energy. The higher the lux means that the higher energy you consume, which is leads to the higher bills on the monthly basis. Okay. Okay, so I think this one I also already mentioned just now, related to the diffuse and direct. Okay, so direct, okay, direct from the sun to the earth, okay, direct. So the diffuse can be some sort of the interference by the sky, okay, and then it can become a diffuse. Okay, this one it's not penetrate; it just go to the upward again, which is reflected, reflect, 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 reflected. Okay, and some of the thing is not reflect, is been absorbed, been absorbed. Okay, so it depends. So normally we will tend to get this kind of irradiance, which is a direct solar irradiance. But normally uh, they will go for the, we also can get some. So total, total, total or global, okay, sorry, not total, global irradiance, okay, is the summation of the direct and diffuse to obtain the global irradiance. Okay, so that's the equation related to the direct and diffuse irradiance. Okay, so the emission of is this one, global irradiance or EG, global, okay, is the submission of the EDIR, direct and diffuse, diffuse. Okay, so this one plus this one to get the global irradiance. Okay, okay, so this is how it's look. Okay, reflection, okay, direct, total irradiance, diffuse, okay, absorb and reflect. Okay, it's a package of the type of the sun ray. Okay, so this is the instrument that we can use to measure the global, direct, or diffuse irradiance. Okay, so for the global, this is the equipment. For the direct, we call this pyranometer for the global, pyranometer. For the direct, direct, we use this one, pyrheliometer, pyrheliometer. So for the diffuse irradiance, we use the pyranometer with the shading ball. This is the pyranometer, which is actually exactly the same with this one. It's just the meter we are putting the this one, the shading ball. Okay, this shading ball to become a shading instrument to be evaluated for the pyranometer. Okay, so in other words, let's say we have the global irradiance. Oh, sorry, we have the pyranometer, this one, which is we determine the global, and then we have this thing as well, the shading ball. Okay, so we do not buy, we cannot buy this one, right? Because we know the equation, the global equal to the direct plus diffuse. So if we have the global and diffuse, we can automatically can get from the equation what is the direct gradients. Okay, there is for that. So simple as that. Okay, so back to your friend's question just now, related to the sorry, I did raise the question. Um, uh, respond to your question, Viren. Okay, we see that by using PV with solar pulse rate system, can we get the um, Yes, I would say yes. Let's say, knowing that the sun is moved from time to time, right? So, and yet we just install stagnantly our PV. Okay. So actually, to obtain the maximum irradiance at any time, we can use the solar tracker to chase the maximum irradiance at any time. Okay. Normally, it will be do or conduct by the system which have um, the, I would say the, seems like the solar farm or etc. Okay, but not for use of the domestic because the tracking devices for the sun is quite expensive. So it incur a cost in terms of the ownership of the PV system. But that's the idea when we do the theory regarding the irradiance. So we need to apply the the angle accordingly, the facing north or south accordingly to ensure that we can obtain the maximum irradiance by not placing the solar tracking. Because normally for the domestic usage, they do not go for the buying the additional equipment, which is the solar tracker, because it will incur the cost to have the system of the PV or the solar system in their house. Okay? But for the research for the solar farm, maybe the thing is quite crucial. So they have their own dedicated solar tracker, which is they have two types, either a two axis or four axis. Um, so so by investing that kind of devices, they can obtain the maximum irradiance at any time. I would say the the difference between the two axis and four axis. I think I can show you in four of this. Where is the start? Okay. So let's say your PV, this is your PV, this is your PV, okay, and then you are buying the two axis tracker to track the sun ray. So you only have the option of this angle only. Okay, this kind of dating. Let's say the sun is here, you go sorry this one, you go this one. Let's say the sun is here, you go this one, two axis. But let's say for the case of the four axis, beside you can go this way, you also can go this way. Let's say the sun is like this, you can go this way and go this way. Four axis. For two axis only this axis. Four axis is can be this axis and this axis. Is that okay? In terms of the um, tracking, two axis and a four axis. But yet to answer your question, Viren, so most of the residential appliances of solar do not invest until that far because by having the information regarding the correct peak angle and also the correct um, and correct facing and also to assess the available sun ray at that particular location still sufficient enough to give the power that they desire to power all the electrical appliances for the dedicated load. Okay, thanks for that. Okay, welcome. Okay, so I off my video. Um, I think I have another one to share. Okay, so knowing the concern or crucial part related to the access of the certain location. Uh, so I think I will share you some of the notes or remarks related to the solar pathfinder. Okay, I will start this one first. Start sharing this one and also try to share. again. Yeah. Hold on. Where's the okay, hold on. Hello guys. Can you see the photo? The solar time? Can you guys see the diagram? No? Okay, yes, okay. Because there's not any what? There's not any signage to show the things. Okay. Where's the thing? Okay, sun pass. Okay, so this is the thing, guys. So this is the sun pass for Malaysia. Okay. Why I say this one is for Malaysia, not for Sudan and for Yemen, because you are referring to this range of 0 degree until 4 degree north latitude. Okay. In other words, for Yemen and Sudan have their own solar path diagram. Okay. So that's what I'm trying to say. So Khalid and Jias, do not use this solar pathfinder for your country because actually you have your own dedicated solar path. Okay. So if you are using this one, you are referring the wrong solar path, which is our movement of the sun is not the same. So that's the idea of having this kind of chart. Maybe we can go for this video for you guys to look with. So try to see this one. So this exercise, so this the video, how to use the solar pathfinder as a part to assess your location of installation of the PV module or array. So everybody can see the roofing house this one before we start.
Sir.
All right. Okay. So we try to play this video. Okay. Yeah. How about the volume? Everybody can hear clearly.
No sound, sir. No sound.
No sound. Are you sure? Hold on. How to? Hold on. Stop. Stop. No sound. How to? Hold on. Stop it first. I think better that way. Share the video. Right? Okay. Wait. Sorry. Stop. So share the. Stop sharing. Hold on. Share. Watch the video. Okay. Sorry. Actually, the problem with
All right, you can see the front of our house here. Some new solar panels. Walk around, see the trees. Nice blue sky. It's about 8 in the morning. Mailbox, a small tree, a large tree. See, the sun is behind this big tree right now. I'm going to set up the solar pathfinder and show you what it shows. Clearly, I'm not getting any sun on the panel, but it's sun's well in the sky in the summer. All right, so I'm in front of the new panels here, and I'm now going to use my solar pathfinder to tell me exactly how much shading I'm getting throughout the year. Let me zoom in on this a little bit. Okay, so the way this works is put this grid on here that faces south. Adjust the rotation of this. So the red part of the compass is facing due north. And then you also level it with this bubble level in the center. So this whole part of the instrument rotates. And what I'll do next is put a reflective dome over the top, and you can see the dark areas will reflect the shaded or dark spots. The light areas is where the sun is coming through. And you can use this along with this chart here to actually predict what percent of sun you're going to get through every month of the year at this location. And you put different rates on here based on the latitude. I'm falling in the 43 to 49 north latitude range. You also make slight adjustments east to west based on your the difference in the magnetic heading compared to due south. And where I'm at, it's very close to right on the zero magnetic declination line. So let me put the dome on. I'll show you what that looks like. Okay, so I got the dome on. You can see the outline of the trees of the house. Some tree shading over here. Actually, the right way to do it is straight down on it. So I'll try to get centered right over that middle bubble level. You can see the shading of that tree that I mentioned earlier off to the east. I got some to my south and some to the west, and then I got up to the house to the north that will block some of the sun for some of the month. So let me take a photo of this, and then I'll, on the computer, figure out how much percent of sun I'm actually getting through at this location. All right, so here's that photo I took. It's a chart showing. You can see on the bottom here, this is the hours of the day. So that big tree that I had to my east, it's blocking the sun. So reading in hours. Here's the 9 o'clock line. It's going to take till about 9 o'clock in the morning. The sun, which right now is over here, and this is up in the sky here, it's actually hitting the solar panels. So clearly, there's a lot of shade being thrown on my panels. That big tree to the east that showed up. I transition. If you look around the horizon, see shading from all of the other large trees from going east to west around near the horizon. That's what we want to try to take a measurement of how much impact that's going to have on solar. The other thing you notice is that the months of the year are shown. In the summer, June, July tend to have about the same amount of time. Sun in the sky, so they're kind of lumped together. Same with April, August, they're paired up March, September. The sun is lower in the sky, you see that's near the horizon. So December, November. Now the numbers that you see in here, this every half an hour, and basically going from beginning of the day to the end of the day, solar day. You add up those numbers, and we come out 100%. You had no shading problems at all. Clearly, we have trees around my house, so I have to subtract those numbers out. The basic idea is to take these numbers that are in the shown in clear and in the sky, add those up, and I'll tell you the percent of the time that the sun is shining. Not being obstructed by trees or any other obstacles. So that's the basic idea. So you can tell my case, I got maybe about 9 in the morning. I should expect to get some solar panels. If it's in the winter time, like December, January, November, these trees here to the southeast blocking the sun all the way up to about 11:30. Then I'll start to get some energy around here. Again, pick up some more trees west, cutting down a little bit on the solar energy. So clearly those winter months are really killing me based on this location. The only saving grace is the trees will have the leaves off, so probably get some light through, but won't show up on this diagram here. It's kind of good summertime, all the leaves. Let's take a look at the anyway, here's a spreadsheet I put together. I just put months of the year. I put every half an hour starting at about that 9 o'clock time frame. So east fell in the winter months here. I basically not getting any sun through it past 11 o'clock where I can start chart solar getting through. Leaving me in the winter months only able to really get access to about 10% time that the sun is up because it's low to the horizon. But for summer months, spring summer months, getting up into the mid to high 80s times, be good for a residential setting. And so I'm fairly happy with the results. Obviously, you want to use this tool to find the best location on your property or on a customer's property. Putting up solar photovoltaic or solar thermal panels so the sun at that location. So anyway, all that helpful. Get this instrument on the internet. About $100. I have to get this one on eBay. $100. Barely even used, but I'll be able to use it on a number of clients' applications to help them out with their projects.
Okay, guys. Any question on that? How to use the solar power finder to access your dedicated location if you want to install any devices related to the solar module or array or solar collector, because that's the, I would say, the very low cost approach how to access your dedicated location or area to install your solar system, specifically for PV module for array and also for solar collector. Okay, so as I mentioned just now, so for Sudan and Yemen, you have your own dedicated sun pass, sun chart, so that you need to use the correct sun chart to avoid any misinterpretation of data. Okay. So next, okay, we try to share another slide of this. Okay, just to strengthen your understanding related to the sun pass. Okay, solar window area sky containing all possible location for area of particular location. Okay, so that's the thing that I try to mention. Every single time have their own, of course, their own pass, and every single day, okay, every single day. So that's why we need to clearly understand what's the behavior of the sun for our references to install the solar system. Okay, so this the how it look like regarding to the sun path for 15 knots latitude, which is more or less like the Sudan and Yemen. Okay, for 45-degree latitude and for 70 knots latitude. So your subject more or less like this. G and sorry. So G and Khalid, your sun pass more or less like this. Okay. More or less. Okay. So for those who are latitude somewhere in 45-degree north, so the sun pass is more or less like this, and this the 70-degree north. Okay. So in other words, the diagram change for different latitude. So this is the keyword. Okay, for the dedicated latitude, they have their own dedicated sun pass for they are referring with. Because as I mentioned just now, every dedicated latitude from day to time, they have on their dedicated sun pass, which is the previous researcher already mapped for us this kind of route of the sun. It's just the matter we are applying this sun pass to map with the existing condition. So just imagine, let's say we are referring this, let's say we are going to Sudan just now, and then we are using this one, this sun site. Okay, let's say at that particular area that we want to install the PV, there's no any blockage at all. So it should be it's a very clear sky and no blockage over here. So meaning that as it is, okay, as like the sun chart side. Okay, so that's the basic thing related to the sun path. Okay, so this is the solar path diagram, which is more or less to the Malaysia condition. Okay, in December, November, October, they have their own dedicated line. Okay. North, south, east, west. Okay, so we skip this one. Okay, so this is the thing. area orientation can be described from azimuth and the angle. Okay, azimuth. So remember, azimuth angle always refer to the south. Okay, always refer to the south. Okay, and then this is the angle, azimuth angle, or on the horizontal angle. Okay, direct radiation, zenith is the straight. Okay, so incident angle, the angle is can refer with. Okay, so this maximum annual energy production. Okay, it's been out sun pass. Okay, so this is the thing. So maybe during the sun or during the equinox, meaning the center, summer is a quite high, is a quite upward, and sun pass, sorry, winter on the downward of the period. With the same or remaining the position of the facing PV. Okay, the angle close to the latitude, or the angle less than latitude, the angle greater than the latitude.